So I'm going to go over Unit 3, Lesson 1 homework. So it says, estimate the perimeter of a square that has a 9 centimeter long diagonal. So we talked in class about comparing the diagonals to the perimeter, and we looked at the relationship and decided that it was, for the most part, proportional. It was a little bit, the line was a little bit crooked and not exactly perfect because of the human and the measurement errors that occur. So if I want to figure out if there's a 9 over here in my diagonal column, what is that constant of proportionality to take me to the perimeter? So we looked at that constant of proportionality in class, but let's go over it again. So 22.8 divided by 8.1 gives me 2.81. 24 divided by 8.5, 2.82. So you're noticing that when you keep dividing down perimeter by a diagonal, we get that constant of proportionality of 2.8. So that means if I have a 9 here, I can take 9, multiply it by the constant of proportionality of 2.8, and it's going to give me my answer. So 9 times 2.8 gives a perimeter of 25.2. Again, not 100% accurate because of that measurement error that we have. Graph the data below. So I have a diagonal to the area. So I'm going to come over to 8. My area is 28.6. So what am I counting by here? 2, 4, 6, 8, 10. I'm counting by 2s. So that means I have 30 and 28.6, maybe somewhere around here. 6 to 20, 22, 24, 25 might be about here. And then 2 directly in between here, 5. I'm going to go 2, 4, 6, 8.5 might be here. So I can see those points. If I tried to connect these and draw a line, let's see what happens. So I would connect up here to here to here. Okay. So is that proportional? I'm going to say no. The pattern is nowhere close to a straight line. Even with human error, a diagonal length is not proportional to the area of a square. Graph the data below. Now we have diagonal compared to perimeter. So I have a diagonal of 8. I'm going to come up to 22.5. So we're counting by 2s again. So maybe somewhere about here. 6 to 16.9. So I have 12, 14, 16, maybe about here. And then I have 5 and 10, 12, 14, maybe about here. Is the relationship proportional? So we can see here that if I grab that line tool and connect it, for the most part, I'm hitting all of my points. Now I know here I'm a little bit off, but that is that measurement error that we're talking about. Whenever we're measuring and making mistakes, it's okay to be slightly off like this, whereas on the other one, we were all over the place. Yes, the general shape is a straight line. Human error causes a few imperfect points, which is okay. Okay. Diagonal to side length. So my diagonal, I'm going to come over to 8, and then I'm still counting by 2, so I have to go 5.6. So 2, 4, 5.6 might be about here. 6, 2 to 4.2, maybe here. And then 5 to 3.5. So let's go ahead and grab the line tool and see what happens. Do they seem pretty close to that line? Yes. The general shape of the graph is a straight line with a few errors due to measurement. Diego made a graph of 2 quantities that he measured and said the points all lie on a line except one, which is a little bit above the line. This means that the quantities can't be proportional. Do you agree? No, that's exactly what we talked about in class. Having a few tiny errors is okay in proportional relationships. Measurement and human error can occur causing things to be imperfect. The graph shows that while it was being filled, the amount of water in gallons in a swimming pool was approximately proportional to the time that passed. So we're approximately proportional here about how much water was in the pool after 25 minutes. So I come over to 25 minutes, my point to be proportional would have to be about here, right? Because we know it needs to be a straight line pattern. So that Y value is 350. Okay. Approximately when were there 500 gallons of water? So I'm going to come up to 500. And then again, I want to be in that same pattern. So my point should probably be about here. Come down here, and that's about 35 minutes. Estimate the constant of proportionality for the number of gallons. So that means I can take a coordinate point. I'm going to take one that seems easy to find. This is a nice point. I have 600 divided by 40, because the coordinates here are 40, 6. Constant of proportionality is y divided by x. So take 600, divide by 40 in your calculator, and you get about 15 gallons per minute.